Bismillahirrahmanirrahim. Assalamu alaikum students. This is Madiha Farooq and today we are gonna start our new unit, that is Introduction to Chemistry, unit number 7, according to your summer vacations homework. So, chemistry. Basically, chemistry is the study of structures, compositions, different properties, physical and chemical changes, characteristics of any matter. It is a branch of science that studies the composition of matter and how to study its different properties and its reactions, and how does it react and form a different and new substance. And basically chemistry involves the use of or the study of elements, its compounds, and elements and compounds are formed with the help of atoms, molecules, and the structural behavior of these molecules, how they form compounds and mixtures, and what are the kind of reactions they go through. So there are some atoms, there are some molecules, there are some elements, compounds, and certain elements that shows the properties of both metals and non-metals are known as metalloids. So the example of a metalloid may include silicon, germanium, arsenic. On the right side there is a diagram of a metalloid, that is silicon and arsenic. Here you can see its diagram. They have the properties of both metals and non-metals. When we study their physical properties, they appear like metals. But when we go through their chemical formation, how its atoms are structured together, then they act as non-metals. So their property is in between metals and non-metals. Now moving on to what is an element. An element is a substance that is made up of different atoms. Atom is the smallest unit, the smallest unit of any structure or any matter is known as an atom. It has certain atomic number, and it cannot be further decomposed into simpler substances because it is itself is a singular unit. For an example, an atom of hydrogen, an atom of oxygen existing in the environment. So atom was first discussed and discovered and drawn through a model known as the Dalton atomic model that was given by John Dalton in 1803. In that model, he said that atoms of a specific substance are alike. For an example, a rubber, a piece of rubber. The atoms of a rubber are alike. Lots of atoms join together to make up a matter known as rubber. So all its atoms are of the same category, of the same characteristics, and every atom joins with the other atom with different kind of properties and form different kind of compound. For an example, water mixing with salt, water mixing with salt gives a salty solution. So, the way in which water and salt are mixed together, different compounds are formed and they combine in a different way how they dissolve in a solution. This is what he is discussing here. And in that model, he described that in a single atom, there is a nucleus in between. That nucleus contains protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, whereas electrons are negatively charged. So a single atom is neutral in charge. And according to that John Dalton atomic model, uh, every element is made up of extremely tiny singular units known as atoms. Atoms of the same element have same size, they are identical, has the same mass and has the same properties. Mass is actually its weight. So atoms further cannot be subdivided into minute particles because it itself is a smaller unit, smaller most unit. So different atoms combine and form another compound known as a chemical compound. When two or different atoms of different elements combine, they give rise to another compound. For example, sodium Na and chlorine Cl, their atoms combine to give sodium chloride, that is another compound known as salt, NaCl. So their chemical reactions, uh, different chemical reactions take place, and this is how we can separate them, rearrange them, combine them. So this was the John Dalton atomic model. Whereas after studying, giving you a brief idea about elements, atoms, and so every atom or element, sorry, every element has a symbol. That is basically its abbreviation. In short, how do we write an element? So these shorter abbreviations are taken from English writings, Latin, Greek, or German writings. For example, sodium, its abbreviation is Na. Oxygen, its abbreviation is O. So this is a table given in which the full names: hydrogen H, helium He, lithium Li, beryllium Be, boron B, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne. Their symbols are written with their valency. So in your notes there's given a full-fledged table of elements and their symbols. You have to learn them by heart. It is important if you want to take chemistry as a major subject in future. You have to learn them by heart, their abbreviations. So kindly go through the rest of the abbreviations as well. Now, atom, the smallest unit of matter or the particle of matter that cannot exist independently. It means that atoms normally combines itself with other elements to form a compound. It normally does not exist freely in nature except certain noble gases. Molecules, these are the smallest particle of an element or a compound. That is a molecule. Two or more atoms make up a molecule. For example, H2, whereas H is an atom and H2 is a molecule. HCl, that stands for hydrochloric acid. So O or Cl or H is an atom, whereas HCl is a molecule. Now, studying what is the difference between an atom or a molecule. An atom is the smallest particle of an element, whereas a molecule is the smallest particle of a compound. So, atom does not exist freely, whereas molecules can exist freely in space. There are some noble gases, for example, hydrogen, helium, that may be present in the environment and are very reactive. Whatever element they see free, they join itself with that atom. Whereas molecules are less reactive as compared to atoms. And atoms do not have any chemical bond, they are free. Whereas molecules are held and joined to other organisms or other elements through a bond. So now I would like to share a picture of a modern periodic table with you all. So this is a picture on which you can see helium, lithium, sodium, potassium, rubidium, cesium, francesium on the left side of the periodic table. These yellow portions are known as alkali metals. The ones that are blue, barium, magnesium, calcium, are known as alkaline earth metals. The orange section in between are known as the transition metals, which change according to moving from left to right side of a periodic table. Whereas the blue section are poor metals and the white section are the non-metals. The red one are noble gases which can exist in the environment freely, and the gray portion on the bottom are the rare earth metals. So this is the basic picture of a modern periodic table around which the whole chemistry or the study of chemistry revolves. So class, we will continue the next section of your unit in my next lesson. You have to memorize the multiple choice questions and the short question and answers by heart and write them on your notes for practice and memorize them. Thank you.